Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This 1 3-mark vector question lost more marks than any other on last year's higher paper, and students called it tricky, when actually the trick is just writing the components clearly. If you hear nothing else today, remember, show your components and you claim the method marks.
Quick promise and recap. Examiners' reports keep flagging the same problems with vectors, messy notation, not using position vectors, and skipping the step that turns a vector into two simple equations. Today, I'll give you a single method that handles every 2D vector question, explain why each step works, and point out the one notation error that costs most students marks.
The concept, component method. Step 1. Start by using position vectors. If you're given points A and B with coordinates, write OA and OB explicitly. For example, say A is 2, 3 and B is 5, 7. Write OA equals 2, 3 and OB equals 5, 7. Then the vector AB is OB minus OA. That gives AB equals 5, 7 minus 2, 3 equals 3, 4. Writing those three items, OA, OB, OB minus OA, is a tiny amount of work that makes everything clear to the examiner.
Why does this work? Because a vector from A to B is the difference between their position vectors, the change in X and the change in Y. Turning a vector into a pair of numbers means you can treat vector equations like two simultaneous equations, one for X and one for Y, and that's where the marks come from. Worked example 1, scalar multiple and solving. Suppose you were told that A plus 2B equals 11, 7, where A equals 2, 1 and B equals 3, 2. First, write the components. A equals 2, 1, B equals 3, 2. Then A plus 2B equals 2, 1 plus 2, 3, 2. Now distribute the scalar. 2, 3, 2 equals 6, 4. So A plus 2B equals 2, 1 plus 6, 4 equals 8, 5. That equals 11, 7 in the question, so check. Here it doesn't match, which tells you either we've misread the question or the value of A or B is different. The important part, every step is shown, and the examiner can see the arithmetic. Worked example 2. Solve for a missing scalar. Example. Find k if 2 minus 1 plus k times 3, 4 equals 11, 7. Write two component equations, 2 plus 3k equals 11 and minus 1 plus 4k equals 7. Solve the first, 3k equals 9, so k equals 3. Check in the second, minus 1 plus 4 times 3 equals 11, not 7, so there's a mismatch and you'd report no solution or recheck the problem. The exam rewards that clear setup. Writing the two component equations is often the M mark on the paper. A common vector question is show that 3 points are collinear. Approach that with position vectors and check whether the vector between 2 points is a scalar multiple of the vector between one of those points and the third. For example, points P, Q and R, write PQ and PR in components, then see if PQ equals T times PR for some T. If both components give the same T, they're collinear. Say PQ equals 6, 4 and PR equals 3, 2. Then PQ equals 2 times PR, so collinear. That simple check is the cleanest way to show the examiner you've got the method.
Exam technique. How marks are awarded. Vector questions are usually a mix of M marks for method and A marks for accuracy. Typical layout. M1 for writing position vectors or expressing a vector in components, M1 for equating or setting up the component equations, and A1 for the correct solution. So even if you don't finish a complicated algebra step, you can often get M marks by showing the right setup. Write the steps the examiner expects.
Examples of exam wording that wins marks.
Let OA equals x1, y1 and OB equals x2, y2. Then AB equals OB minus OA equals x2 minus x1, y2 minus y1. Or for a scalar, let T be a scalar so that PQ equals T times PR. Equate components. X component gives and Y component gives. Those phrases show method and structure. Write them even if you feel awkward. Examiners love seeing the method laid out.
The single notation mistake that costs most marks, not showing components explicitly. Students write something like AB equals 3A or 3A plus B equals 11/7 without writing what A and B are in component form or without showing the component equations. That hides your method. Always expand. If A equals A1, A2 and B equals B1, B2, show the X equation and the Y equation. Also be careful with distribution. K times A plus B must be written as KA plus KB in components, so you don't lose a slip-up.
Quick win, 2-point daily routine. Number 1, start every vector question by writing position vectors OA, OB, or the given vectors in component form. Number 2, immediately write the two component equations X and Y before you start algebra. Those two small steps catch most errors and claim early M marks. Quick win 2, the 10-second notation check. Before you move on, scan your work and ask, have I written each vector as XY? Have I shown any scalars multiplied across both components? If not, fix it now. That 10-second habit saves marks.
Practice prompts. Try these now or on the worksheet. 1. Given A, 1, 2 and B, 4, 6, find AB. 2. If A equals 3, 1 and B equals 2, 5, find K so that A plus KB equals 11, 16. 3. Show that P, 2, 1, Q, 5, 3 and R, 8, 5 are collinear. Each is designed to force you to write position vectors and component equations. The downloadable worksheet on the site gives worked solutions and diagram descriptions so you can follow along.
Teacher and parent tip. Use the printable checklist with 3 steps. Write position vectors, write component equations, run the 10-second notation check. You don't need to reteach vectors to support a student. Just ask them to read their checklist aloud while they work and mark whether each step is shown. That keeps practice focused and helps them internalize the method. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and the downloadable vectors worksheet at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.